Hello everyone, very good evening and welcome to the BYJU'S Exam Prep. Now in this session we will discuss amplifiers by using BJT and by using MOSFET, right? First of all, let me know that sound quality, picture quality, everything is fine. And this is Sanjay Rathi, or this is an important topic, and this is a GATE AIMER'S 2023, a free crash course on analog. Okay, so that is, yes, please let me know that sound quality, picture quality, everything is fine. ओके डन। तो आज हम लोग क्या डिस्कस करने वाले हैं? एम्पलीफायर्स बाय यूजिंग बीजेटी एंड एम्पलीफायर्स बाय यूजिंग मॉसफेट. In this session, I will give you the idea about small signal model, that is pi model and what RE model, and you will get the idea how to connect the circuit, right, and get the gain, voltage gain, or what input resistance or what output resistance, and you will get the idea about the Miller's theorem and important circuits, right? For example, common emitter with RE and common emitter with bypassed RE. So what is the difference between these two circuit and how to handle these two circuit? And then what? Common source amplifier, common drain amplifier, right? Second thing, how to find the Norton's equivalent resistor or Thevenin's equivalent resistor from the small signal model. So Mohan, let me know that sound quality, picture quality, everything is fine. Yes. Then this is an amplifier. It is a very important topic. And first of all, my introduction, myself Sanjay Rathi, and I am having around 21 plus years of teaching experience in the field of competitive exams, and these are my ranks. I have qualified and selected for engineering services exam AIR 16 in ECE 2005, AIR 21 in ECE 2008. I have mentored more than 1 lakh students for these exams. Now we are going to conduct one mock test for you. Tomorrow you can join at 11 AM. Right? Total 65 questions. Same pattern, that is what GATE 2023. 1 marks question, 2 marks question, MSQ, MCQs and numerical answer type question. Okay. So please note the time tomorrow, that is Saturday at 11 AM. Right. Solve 65 questions with us. And this is a quiz. You have to give the answer in comments box. Right. तो कैलकुलेटर, रफ पेजेस तैयार कर लीजिए और आइए मॉर्निंग में सॉल्व करते हैं नंबर ऑफ क्वेश्चंस. सर इट इज फॉर इलेक्ट्रिकल इंजीनियरिंग. यस, इलेक्ट्रिकल इंजीनियरिंग के लिए भी है, राइट? इलेक्ट्रिकल इंजीनियरिंग, इन इलेक्ट्रिकल इंजीनियरिंग देयर इज एम्पलीफायर बाय यूजिंग द मॉसफेट एज वेल एज बाय यूजिंग बीजेटी. No doubt we are getting the straightforward question, but in this session I will give you the direct shortcut how to handle the question. Okay? Okay then. 1 minute. Now, this is for you. Take a step towards success in GATE. Get up to 90% scholarship. If you want to prepare for what? GATE 2024. Then it is a golden opportunity for you. Give the test. Register yourself on BYJU'S Exam Prep official app and what? Official website. Then note the date, tomorrow 10th December at 8 PM. Okay. So that is the scholarship test for you. And now my dear friends, which topics are important from the amplifier? First of all, everyone note this topic. Always we are getting question from this circuit. What is this? This is a simple common emitter configuration. There is no RE. There is no RE. I will discuss each and everything about this diagram, but this is an important diagram. First important diagram for electrical, electronics and instrumentation branch, and that is nothing but common emitter configuration. Now what will be the question? What about this capacitor CB1 and CB2? So that is the first question we will discuss. CB1 and CB2. Second question, what is the voltage gain of this circuit? Voltage gain, or that is called what? Mid-band voltage gain. So mid-band voltage gain. Okay, right, that is AV. or AVS, V0 by Vi. This is called mid-band voltage gain, V0 by Vi. We have to find. Third, you have to find the input resistance seen to Vi or Vs. What is the input resistance seen by Vs? That is another important question. Or sometimes they will ask, what is the output resistance here? What is the output resistance here? So this type of questions from this particular diagram. Now to solve this diagram, we can use RE model. That is also called T model. Or we can use what? Pi model. Now these days we are not using what? Hybrid model, that is H parameter model. Okay. So in a GATE exam, we have to solve the question from RE model or what? Pi model. But remember, in number of questions, no need to use RE model, no need to use what? Pi model. You can direct give the answer. Directly we can find the answer by watching the diagram. Okay. So we have some shortcuts for that. This is the first diagram. No capacitor is connected, no RE is connected here. Right. Second one. In a very simple case, they will not connect any biasing here. This is the biasing is connected. RB will, where this connection will keep this transistor in what? Active region. Okay, sometimes that is RB or potential divider biasing is not given. No problem. Directly input is connected. This is the Vs, this is the Rs, this is the RL, this is the RC. Okay. This type of questions for electrical engineering, straightforward question, there is no biasing, and very simple diagram. Again, always watch this diagram. We are giving input to the base, we are getting output from the collector, and emitter terminal is common, and that's why it is a common emitter configuration. RC is connected, RL is connected, C1 and C2, these are called coupling capacitor, and the value of this capacitor are very large. Very large. Right. So that is the circuit. Now remember, electrical students, I will give you the direct formula how to handle this question. Okay, straightforward direct formula. You can use that formula and you will get the answer for this question. Okay. सर हमने 2024 गेट एग्जाम की प्रिपरेशन अभी से स्टार्ट कर दी है, चाहिए ना? यस दैट इज द राइट टाइम आइडिया. Okay, you will get the sufficient time and you will get the command over the subject, right? 1 year is more than sufficient. Okay, you have more than 12 months in fact. Okay, that is the right time to start your preparation. Okay, so this is another one, RC and RL. So I will give the shortcut for this circuit. Third type of diagram is this one, right? This is RC is connected here, RL is connected here, RE is connected here, then bypass capacitor is connected here. Okay, this is R1 is connected, R2 is connected, capacitors are connected, CC1, CC2, VCC it is given 9 volt and so on. So this is the third important diagram. Again, it is a common emitter because we are taking output from collector giving input to the base. So this is a common emitter configuration with bypassed RE. Bypassed RE. Right, this is the third important one. Again, that is a very easy. Directly straightforward we can give the answer for this particular question. Okay, so we can solve all this question within what? 1 minute. Within 1 minute. I am not saying that within 10 seconds or within what? 5 seconds. Within 1 minute we will be able to solve this particular question. Next one is what? Without capacitor. So sometimes we are getting this question. This is RE, another diagram without bypass capacitor. This is called unbypassed RE, and you will get same type of diagram. And that is here we are capacitor is connected. Sometimes RL is given, sometimes RL is not given here. No problem. RC, VCC, R1 and R2. Here we are connecting the capacitor. Sometimes RS is given, sometimes RS is not given. In 99% case, RS is 0. Directly VS is connected here. But when the RS is given, then what should be the approach? And that is the question. Okay. So how many? 4 types of question. First, second, third and fourth. This is the first diagram. Same common emitter without RE. Then second diagram, no biasing direct straightforward question that is important for electrical engineering. No doubt we can expect same question in electronics, but very easy type of question for electrical engineering. Directly we have to find the gain. Third, potential divider biasing, that is a cell biasing circuit, RE is connected but this is bypassed. Fourth, without bypass resistor. Right. Fifth type of question. Fifth type of question is what? This one. Again we are taking the output from the collector, given input to the base, right, and that is again a common emitter configuration, but here we are using the collector base biasing. Collector is connected to base and it will provide a feedback. This will give you the feedback, and the feedback is what? You have to give me the name. What is the name of the feedback in this diagram? What is the name of the feedback? There are four types of feedback: voltage series, voltage shunt, current series, current shunt. Right? So which type of feedback in this diagram? Current shunt, current series. Four topology. Okay. Now, number of times question on this diagram. When we want to solve this question, we have to apply what? Miller's theorem. Okay. With the help of Miller's theorem, we can solve this question. Then we have to apply what? A small signal model and get the answer. But watch all the previous year questions. Straightforward answer means within 30 seconds we can get the answer for this particular question. No need to apply the Miller's theorem. No need to draw the small signal model. Straightforward formula for midband voltage gain. That is the AVS. V0 by Vs. That is called midband voltage gain. Okay. So straightforward question on this diagram. So this is the fifth one. Right? And now tell me, how many students wants the answer for all these questions? Yes, tell me. Give me the answer in comments box. Straightforward questions. And then on the same line, questions from MOSFET. Similar type of questions from MOSFET. Once you will get the command over the BJT, then MOSFET will become very easy for you, especially AC analysis. Right? Especially what? AC analysis. A small signal model. Draw the small signal model, you will get the gain. Right? So that is the case. So fifth type of question, right? Then common collector. So this is the fifth type from the common emitter configuration. Most important and popularly used configuration is what? Common emitter configuration. 180-degree phase shift we are getting in common emitter. Voltage gain moderate, current gain moderate, but the power gain is highest for this diagram. Highest. Everything is moderate. AV moderate, AI moderate, RI moderate, R0 moderate, but power gain is what? Highest. Power gain is highest. Most popularly used configuration, 180-degree phase shift for this diagram, common emitter. Okay, but when we want to make buffer, then we are using common collector or emitter follower. So there maybe sometimes we are getting that question from what? Common collector or emitter follower. We are getting the output from emitter and we are giving input to what? Base. That is called common emitter or common collector or emitter follower. Now Darlington pair. We are designing the Darlington pair by using the common collector. Common collector followed by common collector, and we are getting the Darlington pair. Darlington pair. That is the part of multi-stage amplifier. Okay. Or sometimes they may ask, what is the swing of the output? Swing. Right. This type of questions from common collector. It is another important topic. Another important topic. Normally we are not getting the question from what? Common base. Right. They may ask, but normally we are not getting the question from common base. But theoretical question. That which type of questions? We are getting the highest bandwidth in case of common base because the current gain is the lowest. What are the property and so on. For example, on the property, input resistance very high for common collector. Right. Output resistance very low. So I will give you the model and how we are going to find the output resistance. And the voltage gain is nearly equal to 1, and that's why it is called emitter follower. Current gain is highest, that is 1 plus beta. Right. Power gain moderate. Power gain is moderate. And the phase shift is 0 degree. There is no phase shift. For positive we are getting the positive, and for negative we are getting the negative. That is the case. So if the voltage gain is 1, so what is the use of this? Because the current gain is very, very high, it acts as what? Buffer. It acts as buffer. Okay. Up to now we have the 6th diagram. Now one by one we will get the command over this. First point. In any diagram, watch this. Yes, try to understand. When we are doing AC analysis, when we want to use the small signal model, remember one thing. In any diagram, first of all the capacitor, all the external capacitor will act as what? Short circuit. Normally it is given in the question that here this is called DC blocking capacitor, that's why B is written, but it is called coupling capacitor also, CC1, same thing. And the value of this capacitor is very, very large, and that's why they will act as short circuit during AC analysis. During AC analysis, this capacitor will act as short circuit. During AC analysis, remember, transistor is in active region, and that's why we are simply making all the DC sources is equal to 0. But remember, when we are making the DC sources 0 means the transistor is in what? No doubt active region. It is in active region. When we want to calculate the voltage gain, input resistance, output resistance, phase shift, that is the part of what? AC analysis. So simply we are making all the DC sources 0. If voltage source, short circuit, current source, open circuit. Okay. Only consider the small signals. Small signals, that is what? AC signal. Okay. So yeah, AC signal ka small signals. Right. Now we are using linear model to solve all this. So first precaution, all the DC sources 0. This capacitor will act as short circuit, this capacitor will act as short circuit, and so on. Then we require DC to keep the circuit in active region, but for the gain calculation we don't require the DC voltage. So during AC analysis we will not consider the VB, ICQ, VC, all are DC analysis. We are using the small signal. That's why it is called small signal analysis. अब देखिए जरा. Now oh sorry, okay. Now what are the small signal model? First, pi model, and second important for BJT is what? RE model, right? In case of pi model, very simple model. Remember that this type of diagram, RB, sometimes RB is given, this R pi is given, RB, base spreading resistor is given, this is the base, that is the emitter, this is for common emitter, and here dependent source, and that is given. This is the collector, this is emitter, and this is called GMV pi. GMV pi, finished. That is the simplified model, right? Or that is called what? Pi model. Okay. Now in every question we have to find the GM. Sometimes that GM is given, or if it is not given, we have to find from this ICQ upon VT. ICQ means DC current, DC biasing current, and VT is what? Volt equivalent of temperature, that is called KT by Q. In a particular numerical they will give you the value, otherwise you can find from T by 11,600 volt, where T is temperature in degree Kelvin. Temperature in degree Kelvin. Or remember this value VT, volt equivalent of temperature, 25 millivolt at 25 degrees centigrade and 26 millivolt at 27 degree centigrade. That is the standard value for volt equivalent of temperature and GM. Now in this same diagram you have to find the R pi also. So what is the R pi? Once you will get the value of GM, R pi is nothing but beta by GM. Beta by GM. find the R pi, find the GM, then we can use this model. What about the RB? They will provide you the value of the RB in the diagram or in a particular question. If it is not given RB, take it what? 0. Take it what? 0. RB, base spreading resistance. Leave it. Right? If it is not given in the question, leave it. And that is called simplified model. Now, what is the RE model? RE model means, here it is given. Again, this is the collector terminal. This is the current IC. And then, this is RE. This is small RE, and that is the emitter terminal, and that is the base terminal. And this is called alpha IE. Right? So current source we can represent. This is the, actually it is a collector current. So collector current is what? Equal to what? Alpha IE or what? Beta IB or what? GM V pi. We can put any value here. So we can write here. We can write alpha IE or what? Beta IB. Yes, all are correct. So in small signal model, or what is the relation between alpha and IB? Alpha is equal to beta upon 1 plus beta. That is the alpha and beta. Now in this model, we have to find the RE. RE is nothing but VT by IE. VT by IE. IE means DC current. IEQ means DC current. So from the DC analysis, first of all find the IE, and then what? You can find the small RE. Right. Sir, it should be dependent current source. Yes. Oh, yeah, देखो. It is a dependent current source. You are talking about the sign only, na? So by default in analog, we are using this type of sign. No problem. In network, we are no doubt. We are saying like this. Sir, dependent source should be shown like this. Okay. But okay, I am writing this. I am giving 5 ampere current. Tell me. I am giving 5 milliampere. No. I am representing what? Alpha I. If I am representing alpha I, means what? It is depends upon the current. It is a current controlled current source. So yes, no problem. I can use here GMV pi. It is a voltage controlled current source. Okay. No doubt. Actually, we have to use the proper symbol. But if suppose it is not given, don't worry about that. Right, Mohan? It is clear? If it is written here alpha I, means this current source has not constant value, 5 ampere or 5 milliampere or 2 milliampere, means it depends upon something. It depends upon the I. So that's why we can say it is a dependent source. Okay. Okay then. Now, small RE. So in this case, we have to find the small RE, or sometimes it is given in the question. Then last point, and then we will solve question. What is the relation here? For example, I want to use the pi model. But RE formula is given. So what is the GM? Mod of IC by VT. Right. What is the IC? IC is equal to alpha I. So I can write alpha times of I upon VT. What is the small RE? Small RE is VT by I. So we will get the relation between GM. So that is nothing but alpha by RE. Alpha by RE. That is the GM. That is the GM, alpha by RE. Or normally what? Beta is very large. Beta is very, very large. Normally it is given beta is very, very greater than 1. So 1 is negligible. Beta cancel, nearly equal to 1. So directly you can use GM is equal to what? 1 by RE, or 1 RE is equal to GM. Finished. Question solved. Right. Directly we can use this formula. Okay then. Now I am giving you the shortcut, how to solve the question, and then we will apply those shortcuts in the question. Okay. First diagram. First diagram, most important one is this is RC. Let this RL is connected here. There is no RE. If there is no RE, then a direct straightforward, this is given here. No biasing is connected here. Simple capacitor is connected. VS is connected here. and we are taking output from this point. Electrical students, direct straightforward question on this diagram. Okay guys, so how we are going to solve this? Okay, you can, from the DC biasing, already I have taken one session for that. You have to find the IE or what RE, and then directly what is the model, we can apply this. Then this CC1 CC2 act as short circuit, VCC will become 0. Now you can use RE model. So what is the RE model? Alpha I, this is the emitter terminal and this is the IE, and that is the base. Now in a small signal model, emitter is connected toward ground. This emitter is connected to ground. So this is the ground. Okay, emitter is connected to ground directly. Then from base to ground, Vs is connected. This capacitor will act as short circuit. First question, Vs is connected. Then from collector to ground, RC is connected because it acts as short circuit, 0. Or this is also act as short circuit, so this is the RL. So from collector to ground RC, from collector to ground RL, and that's why these two are in parallel. Collector to ground RC, RL are in parallel, and that's why what is the equivalent resistance? RL dash. RL dash is nothing but RC parallel with RL. Okay, now this is the collector terminal, and now circuit is over, finished. How to find the voltage gain? Voltage we are taking from the collector, and that's why it is V0 with respect to ground. This is the V0 with respect to ground across RL dash. Mid-band voltage gain, they will ask. Mid-band voltage gain, my dear students, V0 by what? Vs. V0 by Vs. Now V0 we can write, here it is a alpha I, so what is the current here? Minus alpha I. So you can write minus alpha I, RC parallel with RL, it is nothing but RL dash upon Vs. Right, watch this, parallel connection, parallel. So when we are connecting parallel, so Vs is nothing but IE into RE. Directly we can say IE into RE. IE into RE. IE cancel, and answer is what? Voltage gain is given by minus alpha RL dash upon what? Small RE. When the beta is very, very large, alpha is nearly equal to 1. So that's why the answer will become minus RL dash by RE. Remember that, finished. You can directly use this formula. What is this? What is the answer? Common emitter 180 degree phase shift, minus sign, RC parallel with RL upon small RE. Over, within 10 seconds we can solve this question. Minus alpha minus RL dash upon RE, where RL is what? RL dash is RL parallel with RC. If suppose in a particular numerical, if RL is not given, for example, if the RL is not given, remove the RL then. No problem. If the RL is not given, remove the RL. Simply remove the RL. Only RC is there. In this formula only what? RC. In this formula only RC. Finished. Or alpha is nearly equal to 1, and that's why it will become minus RC by what is small RE. Small RE. Remember, but we have to calculate the RE. That is what VT by IE. VT by IE. ये है मॉल लगा दो. Okay. This, I think the first diagram is clear to you. Next one. Then first one. Second diagram. Second one, if RE is connected, then what is the answer? This RE is connected. Then after that, no need to use draw the diagram and so on. No? If it is given directly, capacitor is connected here, Vs is connected here. Here we are taking the output. right? V naught. Now again, during AC analysis, remember one thing, this VCC will act as 0, capacitor will act as short circuit. What will be the model? RE model. Alpha I, small re, this is emitter. Now this time emitter to ground, RE is connected. Connect the RE, capital RE. Now this is ground. This is ground. This is the base terminal. This is collector terminal. Now from collector to ground, RC is connected. If RL is connected here, yes, consider it. RC is connected, RL is connected, both are connected in parallel. RC, RL, they are connected in parallel, and that is the V naught. Here, from base to ground, remember, this is the base, this is R1, this is R2. So R1 and R2 are connected in parallel. From base to ground, R1 and R2. And that's why this R1 and R2 are connected in parallel, because this is ground, that is ground. Here we are connecting the VS. Okay, that is about the question. Now, very simple solution. If it is unbypassed, what is the V naught by Vs? That is nothing but mid-band voltage gain. We can write the V naught is equal to, that current will become minus alpha I, these two resistors are in parallel, minus alpha I RC parallel with RL, that is nothing but RL dash, upon, what is the Vs? This is the Vs, this is the Vs. From this point to this point, that is the Vs. So what is the Vs here? This current is I, so I into Re plus capital Re. Small re plus capital Re. This is finished, this is finished. What is the answer? Minus alpha RC parallel with RL upon small re plus capital Re. That is the exact answer for this question directly. And then you can find again by using this. So if Re is given here, then use direct formula, small re plus capital Re. But again, if the Re is not given, capital Re is not given, only use small re. That is the answer. Okay. So what is the conclusion here? So we are having only one formula here. Right? Direct formula, mid-band voltage gain is equal to, ध्यान दीजिएगा, V naught by Vs is equal to, for common emitter, minus alpha RC parallel with RL upon small re plus capital Re. Right? One formula. Remember, only one formula where alpha is beta upon 1 plus beta. Right? Only one formula. Now, all formula we can derive. First of all, if RL is not given, RL is infinite or not given in the question, so RC parallel with RL will become RC only. So use RC only. Second, if RE is not given, means RE 0, right? Short circuit. This path is short circuit. Or RE is bypassed. RE is bypassed. Bypassed means one capacitor is connected parallel to Re. Then this capacitor will act as short circuit. Therefore, it will short circuit the resistor. In that case, remove capital Re, only small re. So what is the gain here? Gain will become minus alpha RC parallel with RL upon small re. Right. Okay. Or if Re is not bypassed, Re is not 0, so what is the approximate answer? Re is not equal to 0, or Re is not bypassed, unbypassed Re. That is called unbypassed Re. Then, my dear students, always remember When we are calculating the small RE, it is normally 25 ohm or 50 ohm, or it is in the range of what, ohm, and capital RE it is in the range of what, kilo ohm. When the capital RE it is given in the kilo ohm, small RE is negligible. Negligible means from this formula we can neglect small RE. Then what will be the formula for the voltage gain? Minus alpha RC parallel with RL upon what, capital RE. Or beta is very large, then you can alpha 1, it will become minus RC parallel with RL upon small capital RE. RL is not given, then answer will become minus RC by RE. Okay, na? This is the solution for all type of questions. That is what, common emitter with RE or bypassed RE. So directly you can use this one. Right, that is the conclusion. That is the conclusion. So one by one we will now solve 3 questions and you will get the idea about that. But remember, if the RE is given in ohm, suppose capital RE is given in ohm, 100 ohm, then you have to consider what, small RE. So sometimes students are using direct this formula. Why? What is the approximation? RE, if it is in kilo ohm, then capital RE is very greater than small RE. Then we can neglect the small RE. Otherwise, otherwise you have to use the small RE plus capital RE. This is the exact one. Okay, remember, comparative term. Okay then, now first type of question, like फटाफट use करते, that is the use of this. What is the formula? In the following transistor circuit, VB is given 0.7 volt, RE is 25 millivolt divided by IE, and the beta and all the capacitances are very large. If the beta is very large, what is the alpha? Tell me, give me the answer in comments box. If the beta is very large, what is the value of the alpha? Midband, we are calculating the midband voltage gain of the amplifier is approximately. Watch this diagram. Watch this diagram. RL is given here, RC is given here, RL is given here. This RE is bypassed. This RE is bypassed with the capacitor C. Right here, no RS, directly VS connected. This is the R1, that is the R2. My dear students, in this question, midband voltage gain directly become V0 by Vs is equal to minus RC parallel with RE upon small RE. Directly we can write. How? Beta is very large, then alpha is what? 1. Yes, Satya, your answer is correct. Beta is large, so alpha become 1. And what is the formula? RC parallel with RL, not sorry, RE, RC parallel with RL. RC parallel with RL upon small RE. Why small RE? Capital RE is bypassed. Finish. That is the voltage gain. But how we are going to calculate the small RE? So that is the answer for this question. Right? RC parallel with the RL and small RE. Now, how we are going to find the small RE? So small RE is nothing but VT by mod of IE. VT is given as 25 millivolt. You have to find the IE. Remember, this is in millivolt. Okay. Then you have to do the DC analysis. Very simple. How we are going to do the DC analysis? Remove DC. For DC analysis, always remember the capacitor acts as open circuit. Remove this capacitor. So this resistor is removed. This capacitor is removed. This capacitor is removed. Now we are having this value. 10 kilo ohm, 20 kilo ohm, 3 kilo ohm. Apply what? Thevenin's equivalent. So what is the VTH? VTH will become 10 divided by 10 plus 20 into 9. This is the 9 volt. So what is the voltage here? 3 volt. No need to calculate the RTH because the beta is very large. So you are giving the answer D, yes. So then what is the question? This is the case. 2.3 kilo ohm is given. Only VTH 3 volt. What is the value of the VB? 0.7 is given in the question. 0.7 silicon transistor. Now you can find the value of IE. Directly apply the KVL in this loop. When I am applying the KVL in this loop, then What is the IE? IE will become 3 minus 0.7 divided by RE, that is the 2.3, 1 milliampere. Finished? 1 milliampere. 1 milliampere, so what is the small value, the value of small RE? 25 millivolt divided by 1 milliampere, milli cancel, 25 ohm. 25 ohm. Okay. Now, no need to draw the small signal model. No need to draw the small signal model. Directly use this formula. So minus RC parallel with RL. Minus 3 kilo ohm parallel with 3 kilo ohm upon 25 ohm. Remember, it is in kilo ohm. So it will become minus 1.5 kilo ohm, and that is what in ohm. Please convert this in ohm. So you will get minus 1500 ohm divided by what? 25. And that is nothing but minus 60. Minus 60 is the answer. Is there any use to draw the small signal model? Tell me. No need to draw the small signal model. Direct small, get the formula, get the current, and you can give the answer for this particular question. Minus 60, 180 degree phase shift. Okay. Remember, but if it is bypass, then you have to use the small RE, remove the capital RE. But what is the use of this capital RE? Because it will provide the self-biased during the DC analysis, and that's why during DC analysis we are considering the capital RE. We are considering the capital RE. Okay. The next one, similar type of question in what? Okay, 1 minute. ये तो हो गया. दूसरा 1 मिनट रुकिए. One. This one. Again, same type of question in engineering services exam. An amplifier circuit is shown in the figure. VT is given as 25 millivolt. The voltage gain V0 by Vs is equal to 4 by 3.33, beta 100, C160, 200. Right. Now, normally students are giving the shortcut RC by RE. RC by RE. There is no RL. There is no RL. But my dear, this answer is correct when there is no capacitor. Capacitor is connected parallel to that. So it is a bypassed RE. If it is the bypassed RE, again tell me what is the voltage gain? Minus RC. What about the RL? RL is not given in the question. Remove. Minus RC upon small RE. What about the alpha? Beta is not given in the question. Beta is given. Okay. HFE is given 150. Okay. Beta upon 1 plus beta. 150 divided by 151 nearly equal to 1, or you can use this formula, but it is nearly equal to 1. And always watch the answer. The difference is very, very high. It will no need to consider the exact value. You can take alpha is equal to 1 because beta is very, very large. No problem. Now, answer we have. What is the voltage gain? Minus RC by small RE. Find the small RE. What is the small RE? VT by I. VT by I. So, again DC analysis. So, DC analysis, capacitor act as open circuit. This capacitor will act as open circuit. No need to get the output. This capacitor will act as open circuit. Potential divider, alpha is again, beta is again very large. 150 means very large value. So, directly apply the potential divider. So, ये हो गया 30 divided by 30 plus 60 into what? 12. And that is nothing but 3 by 9 into 12, that is 4 volt. Once you will get the 4 volt, this is connected. No need to calculate the RTH because base current is 0. This voltage is 0.7 volt, and what is the RE? 3.3. Similar type of question. Again we are getting the 1 milliampere. 4 minus 0.7 upon 3.3. I, capital I, DC current. 4 minus 0.7 upon 3.3 is equal to what? 1 milliampere. What is the small RE? 25 divided by 1, that is again 25 ohm. Similar question. 25 millivolt VT and 1 milliampere is the current. Similar question 1. Now, once you will get the small Re 25 ohm, what is the answer for this question? 4 kilo ohm. So what is in ohm? 4000. What is the value of small Re? 25. Tell me which answer is correct. Everyone in comments box give me the answer. Minus RC by Re only. Because RL is not given. Yes. Right, and that is the case. Tell me what is the answer? 160 is the answer. Yes, Surya. 160 is the answer for this question. Right. And again we can design one extra question on that. Remove the capacitor here. Remove the capacitor. If there is no capacitor, then answer will become. What is the answer? Tell me then in that case. If the capacitor is not, answer for this question is 160. But if the capacitor is not given, then what is the answer? Capacitor is not given, then what is the answer? If the capacitor is not given, then the answer is minus RC upon small re plus capital Re, because RL is not given. Minus 4000 kilo ohm. This is 25 ohm. And what is the value of the capital Re? 3.3 kilo ohm. 3300 ohm. So remove this. 25 is very, very less. So capital Re is very, very greater than small re. You can neglect capital Re and answer will become minus RC by Re. In that case, answer is minus 4 divided by 3.33. 3.3. In that case, answer is what? 4 by 3.33. Directly. Here, 3.33. 4 by 3.33. That is the answer. Okay. So, shortcut. Directly we can apply the shortcut. So, actually we are neglecting the small re from the denominator. We are neglecting the small re for the denominator, and that's why that result 4 by 3.3 is overestimated. It is magnitude is overestimated. Overestimated means during approximation we are neglecting the small re for denominator. Denominator will become smaller. So what about the overall magnitude will increase, right? So that is the overestimated. Okay. Okay, that is the standard question. Next one. Next question is this diagram. This one. Number of times question on this diagram, no doubt. But what is the method here? Approximate answer is this is RF, this is RS. This is RF, this is RS. Remember, directly you can give the voltage gain AVS is equal to V0 by Vs, that is equal to minus RF by RS. Minus RF by RS. And that is the answer from what feedback mechanism, and the feedback mechanism is voltage shunt feedback in this diagram. What is the name of the feedback? Voltage shunt feedback. The electrical student or electronics students, directly we can apply that RF by RS. So what is the value of the RF? 100 kilo ohm. What is the value of RS? 10. 100 divided by 10, answer is minus 10. What is the magnitude? 10. Again remember, it is the overestimated value. Means actual answer is less than this. Actual answer is less than this. But it is the overestimated value 10 only. My dear, watch the 4 options. 200, 100, 20 and 10. 10 is the lowest answer. Again it is overestimated. Actual answer is less than 10. Answer, that's why D is the correct one. Or in a GATE exam, in numerical answer type, if it is written approximated value, then you can use direct formula. 1 mark question or 2 marks question. Directly RF by RS. RF by RS. Otherwise, if you want to connect it, all these things in a RE model, and then it will become very lengthy. No doubt, we can solve by using the network, concept of network, right? Okay, and then finally we will apply the approximation, and again you will get this same answer for this particular question. Okay, so that is the between collector and base. One resistor is connected here, right? And that is the RE. Emitter is connected toward ground. Okay. Right. 1 minute. Now tell me, what is the answer for this question? Similar question. What is the answer for this one? क्या होगा भाई बताओ. And if you want the PDF, then you can join my Telegram channel. I am sending the link with you. I am sharing the link with you. Okay. Then this is the link for my Telegram channel, Electronics by Sanjay Rathi. Okay. So what is the answer? -10. Yes. Directly. This is 53. This is 5.3. This is RF. This is RS. 53 divided by 5.3 with minus sign, 180 degree phase shift because it is a common emitter. -10. Or it is overestimated. So two value is given. -10 plus 10. So this is the -10. Value is what? -10. Okay then. तो अनदर वन, तो ये है शॉर्टकट, लेकिन मॉडल में भी कनेक्शन करना आपको आना चाहिए. आप देखते हैं अगला एक और मैं क्वेश्चन आपको बता दूं. Sometimes they will ask, what is the use of this bypass capacitor? Why we are connecting this bypass capacitor? So remember, this is a very general question. What is the use of this bypass capacitor? So when we are not connecting the bypass capacitor, so watch the previous question. When we are not connecting the bypass capacitor, then what was the gain for the system? When we are not connecting the bypass capacitor, this is not connected. So what is the gain? Only 4 divided by 3.33, nearly equal to 1, nearly equal to 1 point something. Very small gain. So when we are removing the bypass capacitor, the gain will reduce because of negative feedback across RE. Negative feedback across RE. But when this bypass capacitor is connected, RE is bypassed, what was the gain? 160. With numerical, you can understand what is the change in the gain. From 160 to it will become nearly equal to 1. Right? And that is the change. That is the change in the gain because of the negative feedback across RE. Remember, so when we are removing the capacitor, gain will increase, gain will decrease. When we are connecting the capacitor, the gain will increase. But why we are connecting the capacitor? To stabilize the gain, to increase the bandwidth, to make the system stable, and to increase the input impedance. To increase the input impedance. Always remember, we can increase the input impedance by using this. So there may be one question on the input impedance. So I am giving you the one simple input impedance concept here. How to calculate the input impedance? If this is small RE, this is the capital RE that is connected here. This is the model. Always remember, when we are connecting the VS, everyone tell me what is the input resistance. Let this is the 100 ohm, it is the 1 kilo ohm. What is the input resistance seen by the VS? What is the input resistance seen by the VS? Everyone please tell me, what is the input resistance seen by the VS in this diagram? What is the input resistance seen by the VS? This is the base terminal. This is the emitter terminal and that is the collector terminal. Here we are connecting the load and here we are getting the output. That is the model. We are connecting like this. So what is the input resistance here? So let the, this is given as 100 ohm, this is given as 1 kilo ohm, or we can calculate the RE by using the formula. If the input resistance is asked, then always remember one thing. Some student will give the answer, sir, input resistance seen by this VS is what? Small RE plus capital RE. They can say small RE plus capital RE, that is 1.1 kilo ohm. But what is the current given by this? Base current IB. In this branch, this is the base current. And what is the current in this branch? It is not the base current, it is the emitter current. It is not the base current, it is the emitter current. And always remember, what is the resistance seen by any battery? Input resistance seen by any battery is Vs upon what? Current given by that battery. So current given is IB. Vs upon IB. But when I am writing the KVL here, when I am writing the KVL in this loop, I can write it Vs is equal to I into small re plus capital R. Small re plus capital R. But we want the ratio of what? Vs upon IB. So what is the relation between IE and IB? Vs is equal to 1 plus beta or 1 plus HFE times of what? RE? IB. This is the IE and this is the relation between IE and IB. HFE or beta into what? RE plus capital RE. Now, what is the Vs by IB? Vs by IB, that is the input resistance seen by the Vs, it is 1 plus HFE times of what? Small re into plus what? Capital RE. Remember this formula. Small re plus what? Capital RE. That is the resistance. Okay guys, this is clear? Oh, is it audible or not audible? Yes. Yes, please. Okay. Okay then. So you can write the KVL here and you will get the RE. So what is the input resistance? Directly, if it is not visible, then I am writing here 1 plus HFE times of small re plus capital RE. Now, if suppose the small re is bypassed, if suppose the capital RE is bypassed, then what will be the input resistance? Everyone tell me. It is unbypassed RE. It is unbypassed RE. If it is bypassed, then what about the input resistance? Input resistance will simply become 1 plus HFE into small re only. 1 plus HFE into small re only. Input resistance decreases. Input resistance decreases. Extra term is cancelled out. 1 plus HFE capital RE. Right? It is decreased by what? 1 plus HFE into capital RE. That term is not present here. And that's why when we are connecting the capacitor, no doubt the gain will increase, but input resistance will decrease. So this type of questions. So that is the direct 2 marks question. 2 marks question in GATE exam. Okay. So always multiply it with what? 1 plus RE. Then solve this question. Now you can give the answer for this one. Already I have solved one numerical, how to find the input resistance. Then the amplifier circuit shown below uses a silicon transistor. This is a silicon transistor. The capacitors CC and CE can be assumed to be short at signal frequency, no doubt. They are very, very large. And that's why they will act as short circuit during what? AC analysis. The effect of output resistance R0 can be ignored. Early effect is negligible. If C is disconnected from the circuit, which one of the following statement is true? So simply we are removing